Welcome to today's explainer, everyone. But honestly, I want you to think of this less like a standard review and way more like a Silicon Valley Cambridge exam hackathon. I'll be your lead dev for this session, and today we are setting our sights on a very specific mainframe, the Cambridge AS and A-level mathematics syllabus. Specifically, we're cracking into topic 3.9, complex numbers. Look, we are going to treat this exam paper not as some unsolvable mystery, but as a literal system of code. It's all about the syntax, right? If you truly understand that syntax, the modulus, the argument, the conjugate, you can completely optimize your responses for maximum marks. So get comfortable, clear your workspace, and let's boot the system up.
So, right off the bat, here is the million-dollar high-stakes question to start us off. Why do otherwise brilliant students lose incredibly easy marks? To explain this, I want to introduce you to two hypothetical coders we see in the exam room all the time. First, we have Dev Alex. Now, Alex is incredibly fast at raw data inputs, just punching numbers into a calculator like an absolute machine. But Alex causes massive memory leaks because of poor analytical planning and totally unstructured presentation. Then we have Dev Sam. Sam is amazing at building logical loops and can see the big picture of a math problem effortlessly, but constantly fails basic syntax precision rules, forgetting a negative sign, mislabeling an argument. In both cases, the whole program crashes. We are here today to debug that exact command matrix so you don't make those same errors.
I want you to look at this insider insight straight from the senior examiner's playbook. They explicitly state the difference between a B and an A star often comes down to how well you understand 3.9 complex numbers. This isn't just some minor subtopic to gloss over, guys. This is the literal firewall between average performance and true A star mastery. Master the modulus, the argument, and the conjugate, and you essentially give yourself root access to top-tier grades. Here is our command matrix for today. We'll define the B versus A star difference, map out the core conceptual principles, compile the method mark strategy, run a critical evaluation protocol, and finally, review the top examiner warnings. Let's initialize section 1, the B versus A star difference. To truly understand the difference between standard and optimized responses, we have to look at the foundational definition. For A-star candidates, complex numbers are not just isolated formulas to memorize. No, they represent a complete theoretical architecture. This architecture relies heavily on precise definitions and the causal relationships between the modulus, the argument, and the conjugate. If you only memorize the formulas, it's like you're just memorizing single lines of code without actually understanding the software you're building. You absolutely have to understand the fundamental principles of how these elements interact to keep your system stable.
Moving on to Section 2, Core Conceptual Principles. Let's look at how to structure this.
Now, what's really interesting about this slide is that when we look closely at the principal examiner reports, it's crystal clear what top candidates actually do differently. They exhibit what's called a connected understanding. They don't just solve the math in a vacuum, they integrate it. They apply systematic analysis and evidence-based reasoning. They can transfer their skills to totally unfamiliar, weird contexts. And here's the ultimate cheat code to clear the examiner firewall. Examiners explicitly note that candidates who reference cross-topic connections, meaning they integrate complex numbers with other syllabus areas like trigonometry or polynomials, achieve significantly higher marks. It's about showing the examiners you see the whole matrix, not just a single string of isolated data. This is exactly where our coders, Alex and Sam, need to sit down, debate their pseudocode, and map out a response outline before they even start writing. All right, initializing Section 3, the method mark strategy. Okay, let's dive right into this and shift our focus from the abstract theory to the actionable mechanics. But actually, hold up. Halt the compile screen. Before we push this final patch to secure your maximum marks, we need to optimize your system feed. Subscribe to Ace the Exams, that's @ Ace the Exams, right now. Hit that button and turn on all notifications for our weekly system updates. You don't want to miss a single patch. Okay, resuming the compile. In the Cambridge system, marks are frequently awarded simply for the process, for showing your algorithmic workflow, even if your final output has a math bug in it. Solving these multi-part problems is a linear, repeatable sequence. It's an algorithm. Think of it like the classic Peel paragraph syntax: point, evidence, evaluation, link, but adapted for high-level math. Step 1, deconstruct the question. Step 2, extract the relevant given data. Step 3, select your analytical framework. Step 4, execute with absolute clarity in your notation. And Step 5, present the final output with correct terminology. If you treat every single problem like this, you systematically lock in method marks at every line of code. And this brilliantly illustrates why your scratchpad, your working out, matters so much.
Systematic processing relies entirely on clear working to verify your results. Examiners want to see your code. They actively award marks for showing this rigorous framework. Never just leave a blank space in a final answer. Show them the build process.
Transitioning to Section 4, Critical Evaluation. This is where we stress test everything. Welcome to the interactive beta testing arena. I want you to really look at this comparison on the screen. On the left, we have the generic approach. This is Dev Alex, your average B candidate who relies entirely on rote memorization scripts. They just plug numbers in and pray the code compiles. On the right, we have the evaluative approach. This is the A-star candidate. Let's run test 1. Imagine a 60-second visual countdown clock on your screen right now. If you're handed a complex data chart or a massive text block about an Argand diagram, can you extract the trend before the clock hits 0? Evaluative candidates don't just calculate. They question the assumptions of the math. They evaluate the evidence, and they check if their final output actually makes logical sense. Evaluative thinking is literally your ultimate debugging tool. Let's run test 2, a quick code review. The Cambridge framework demands that you look incredibly closely at the quality of the evidence you're working with. You need to identify limitations, recognize the assumptions made within the problem, consider alternative interpretations, and most importantly, justify your final decisions with hard evidence. If you hit a logic error mid-argument, you deploy this evaluative syntax structure to debug and upgrade your paragraph instantly. Does locus make sense? Is the angle in the correct quadrant? Check the reasonableness of your results. Let's load up our final module, Section 5, Top Examiner Warnings. I'm going to drop my tone slightly here, guys, because these next points are fatal system errors. The examiners have explicitly flagged 3 major recurring pitfalls. These are 3 massive bugs in candidate coding where students routinely throw away incredibly easy marks on topic 3.9. Let's run this code review and patch these vulnerabilities right now. Here they are. I want you to mentally audit your own exam habits right this second. Mistake 1. Students forget to include the proper format for modulus and argument. They calculate it, but they write it down in a completely non-standard format. Mistake 2. They fail to check their presentation and working. It's too messy, the examiner can't read the logic flow, and boom, method marks are gone. And mistake 3, which is the biggest system crash of all, providing answers that are not specific to the context given in the question. Let's isolate that last one, because it is the classic mistake, providing generic answers instead of contextual ones. Listen, you could have a perfectly executed mathematical calculation, an absolutely brilliant script, but if you output a generic textbook response that completely ignores the specific scenario of the past paper prompt, your grade firewall comes down immediately. It is the absolute quickest way to ruin a perfectly good score. So, your cheat sheet architecture comes down to this golden rule from the examiners. Always link every point to the given scenario. Never leave your math hanging in a void. Tie your modulus, tie your argument, and tie your conjugate directly back to the physical or theoretical context that the specific question provided. This is your ultimate examiner alert and the most crucial takeaway for compiling your final high-scoring text string. I want to leave you with this final thought to process. Will you treat your next past paper as just a simple calculation or as a rigorous test of context and evaluative architecture? Apply this framework, lock in those method marks, and keep debugging those past papers. Now, before you log off, I need you to do 3 things to finalize your code deployment. Subscribe to Ace the Exams, @handle Ace the Exams, click that notification bell, and leave a comment down below with your specific subject and level so we know what system to hack next. See you in the next update.